All right, we're looking at question 23. It says, what's the domain of a geometric sequence? Remember, a geometric sequence is where you multiply to get from one term to the next. Okay, and when we're talking about sequences, okay, we use whole numbers. So we can't have like a half or anything like that. So for this one, we would say that our domain is all whole numbers. So we'd say a set of all whole numbers. Alright, and so it would be 1, 2, 3, 4, etc. Alright, let's look at 24. 24, we're given 2, 6, 18, 15. Alright, first of all, let's come up with the common ratio or the constant ratio. So we do that, we take the one behind and divide. So 6 divided by 2 gives us 3. We could do the same thing with the 18 divided by 6, which is 3. So our ratio is 3. Okay, then the b, we had to come up with the equation, the function a sub n is equal to a1 times r to the n minus 1 is the general form of the function for a geometric sequence. Okay, so what we're going to do is replace a1 with 2. Okay, r is 3, and so that's our function. Okay, which would be a growth function. Okay, because we have this exponent, and the base is larger than 1. Well, the absolute value is larger than 1 with this. Alright, and then C, we actually had to plug in 10 to come up with an answer. So a sub 10 is equal to 2 times 3. We put in 10 for n. Okay, so we end up with 2 times 3 to the 9th. Okay, and so we're going to plug that in the calculator. And so 3 to the 9th power gives us 19,683. Multiply that times 2. We should end up with 39,366 for our 10th term. So you can see it gets pretty large pretty quick. Alright, for question 25, another geometric sequence. Alright, so we can find our ratio by taking any two in the sequence. So I'm going to take 1 over 3, and that gives me a third. So that's our ratio. Now I could do the same thing with 29 and 27. I'll have to reduce this, but you still should end up with a third for your sequence. So our general form again was a sub n is equal to a1 times r to the n minus 1. a1 is 27, r is 1/3, and we're taking that to the n minus 1 power. Okay, so that would be our function. Okay, and then we're going to plug in 8 to see what we get for our value. So a sub 8 is equal to 27 times 1/3 to the 8 minus 1. So we end up with 27 times 1/3 to the 7th power. Now when you do this, you can put this in the calculator, but if we take a third, you may want to put a third in parentheses, so it doesn't just take the 3, but it would be fine for this case. But so when 1 divided by 3 to the 7th power times 27, we should end up with a decimal answer, and so I'm just going 3 decimal places. So let's go 0.0123, and so our 8th term would be equal to this. Now if you did it in fraction form, you could take 3 to the 7th power, which is 2,187, and then we could reduce this. And we could end up with 1 over 81. Now, if it's on a multiple choice test, if you come up with a decimal answer, just divide 1 by 81, and you come up with this. So you can see which one matches up. Alright, question 26 is another geometric problem. Alright, so the common ratio would be 4 over 2, which is going to give us 2. We could take 8 over 4, 16 over 8. We end up with 2. That's our common ratio. Alright, so our equations, our function is going to be a sub n is equal to a1, which is 2 times our common ratio of 2 to the n minus 1. Now don't multiply 2 times 2. The temptation is to do that, but you can't do that. Now it may work out okay on this one. I doubt it, but you can't multiply these. You have to take the exponent first. So that's our B part, and then finally for the C part, we're going to find the 9th term. So a sub 9 is going to be equal to 2 times 2 to the 9 minus 1. So you get 2 times 2 to the 8, okay, or 512. Okay, so that's geometric sequences. Alright, on problem 27, we have bus routes, and they want us to label it RT. Alright, so our routes are going to be T, and then T minus 1 divided by 2 would be our function. Then we're going to plug in 5 so that we get 5, and then 5 minus 1 divided by 2. Go through the process and we end up with 10. Okay, then if it goes up for the C part, if it goes up to 6, we'll do 6 over 2, so we end up with 15. Alright, for question 28, okay, you got to kind of read through it, but this is going to be an arithmetic. Now, he says if Paul starts a new company that will build guitars. Alright, he says the first month he's going to build 15. So that's what he's going to start out building. And then each month after that he's going to build 5 more. So we're given the sequence actually. We're given 15, 20, 25. Okay, but this is arithmetic because we're getting there by adding 1. So he starts out making 15, so that's A1. Our common difference is 5. Okay, so it says write a function. So the way we do that is we know a sub n is going to be equal to a1 plus d times n minus 1. Okay, so a sub 1 is 15, common difference is 5. Okay, we're going to distribute our 5 through, so we get 15 plus 5n minus 5. Combine like terms, so we're going to combine the 15 and the 5, and we'll get 10. So a sub n is equal to 10 plus 5n. So that would be the function, and we could plug in any number of months in for n and figure out how many guitars he should be making. Alright, now it says for the B part, it says write a function that represents the total. Okay, so we have to remember that for arithmetic, S of n is going to be equal to n, then a1 plus a sub n. That is what we're going to plug in there. So S of n is equal to n. N we don't know what is. We do not know what n is. Okay, now a1 we know was 15. He started out making 15 guitars. And we just saw for a sub n, so we're going to take this and plug it in over here. So it's be plus 10 plus 5n. Okay, so now what we're going to do is simplify this. Let's go ahead and combine like terms inside the parentheses. So it's going to be 25 plus 5n. Okay, because we're just adding the 15 and the 10. Okay, then we're going to distribute the n through so that we end up with 25n plus 5n squared over 2. So if we want to know what he's making in the 8th month, how many total he's made for the whole time, we can put it in here. If we want to know how many he's making that month, we'd put it in this one. Alright, so let's look at C. C, they're wanting us to come up with a total. Okay, so it says what's the total? So total after 12 months of the first year of production, so that's 12 months. So what we're going to do is S sub 12. So after 12 months, how many guitars has he made? Well, we'll replace the n's with 12s in our formula that our function we just came up with here. Alright, and so then we plug all this in, and we end up with 360 plus 150, all divided by, no, it's not, we already divided by 2. So we do 360 plus 150 for a total of 510. So after a year, he's made 510 guitars. Alright, I want to make sure I have enough time, so I'm going to finish this up on the next video.